I'm sure it caught a little bit. Anyway, welcome to the September 2024 meeting of the Baton Rouge Astronomical Society. We took a month away from the streaming duties so we could go have a special, or 2 months away for various things, and the summer and whatnot. But we're now back live, and we should have a couple of more months before we go dark again for our winter meeting and our food party reasons. Anyway, I'd like to introduce our guest for tonight. This is Amy Northrop. Yeah, okay. She got married a few years back, and I never can remember the name she never said. I'm not turning around anymore. Well, I did. Thank you. Anyway, she is graciously agreed to come speak with the club about the Europa Clipper mission, which is going to be launching here in the next few weeks, we hope. And it is very exciting. It's part of the grand tour of Jupiter and the moons of Jupiter and the star exploration of the solar system. It's really cool stuff. NASA is our solar system ambassador. There are a few of them in Baton Rouge, but she is actually pulling all this information directly from NASA. As a reminder to club members, if you have a question she can't answer, she'll go to ask her higher ups, which is exactly how the last time she did the talk, we were able to figure out, and we queried NASA as to who would win in a drag race between the NASA crawler, space shuttle crawler, and the Mars rover. And boy, were we all surprised about that. It turns out that the crawler just smokes it by quite a bit. But anyway, if you have questions for her that she can't immediately answer, do ask them anyway. She'll write them down, and she'll go ask somebody who can answer them. And we like to embarrass her with really wild ones.
Oh dear, it sounds like I'm gonna need a pen to write down all the crazy questions.
I hope so. Anyway, Amy, please take it away. Thank you so much.
Okay, I am a NASA Solar System Ambassador with NASA JPL. My views and what I say in the presentation don't reflect anything of the observatory or its partners or NASA and its partners. I am a private citizen who just does volunteer work for NASA. So, first off, what is the target? Europa is Jupiter's second large moon. It is in a gravitational resonance with two of the other Galilean moons, Io and Ganymede. Io goes around 4 times for every 2 orbits of Europa and 1 orbit of Ganymede. So they constantly are playing tug of war with each other with gravity. And when you add Jupiter into the mix, this causes a lot of interesting things to happen with their interiors. For example, Io is the closer moon. If you were on the surface of Europa facing Jupiter, you could actually see Io zipping around, and you could also see eruptions happening because that is what happens when you have Jupiter's gravity and multiple moons the size of ours running around. The moon I mentioned, Ganymede, is actually larger than Mercury, so there is quite a lot of gravity at play here. So why Europa? They say it might have twice the liquid water Earth does. It might have the elements necessary for life, and it might have energy necessary to support life in an ecosystem. Okay, that checks out. Sounds interesting. So what are we sending there? Or what are the goals of the mission? First, we're going to try and prove Europa's oceans exist. They found that there are some fractures, which you can see here, that don't fit with the expected patterns of fracturing that you would expect from normal tidal activity. They determined it would only fit if there was an ocean underneath this icy crust. And they did some math and figured that the ocean has the potential to have twice the volume of liquid water that Earth has. They used this information to get funding for the Galileo mission, which they sent there in 1989, and it entered into orbit in 95, and it found that there could in fact be an ocean. It supported the data. They only did 12 flybys, and it was actually so successful at supporting the belief that there might be life or water that they chose to end the Galileo mission by crashing it into Jupiter. This is now a tradition with the Jovian spacecraft. We don't want to risk life on the moon, so crash into planet Jupiter and it'll take care of it. They hope to confirm the actual existence of the ocean and its exact size. If the ocean exists, the tides will actually deform the surface by up to 30 meters. If the moon is frozen solid, it'll only be tidal shifting of about 1 meter. So. They're also curious about the reddish. You can see the red. They're curious about the composition of that on the surface. And they're hoping that the JUICE mission, which is being done by ESA, it stands for Jupiter Icy Moons Explorers. This was actually supposed to be a huge, elaborate OWOP mission, but things fell through, and it's now 2 separate missions, and the objectives have been dialed back a bit. Instead of being a sweeping survey of all 4 moons, we're going to study Europa, and JUICE is going to focus its explorations on Ganymede with occasional observations of Europa. And we'll be coming back to Ganymede in a bit. In addition, they're also hoping that the proposed, it hasn't been approved or even given construction yet, but they're hoping that there will be a Europa lander mission that can actually land and do studies on the surface. Well, next we need to figure out if the chemistry is right. There are certain compounds that need elements, rather. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, which make up 90% of living materials. They form organic molecules, and we're hoping if they have the organic molecules, this means that they have the building blocks for life. This actually made a bit of a stir because they actually found out a few years ago that Titan had similar compounds. So they're hoping that Europa, with its nice, huge ocean, also has it. Now, part of the problem is you've got a thick layer of ice, so we're going to have to try and figure out what is going on underneath this ice. And they're also thinking that the tidal flexing of the material underneath, like the rocky crust above the ocean, or below the ocean, may actually be contributing to that. Similar to the deep sea vents we have in some of our oceanic trenches. Most people have seen images of those giant tubes that look like a tube of lipstick that you see in deep sea vents. Creatures like that, but something that would probably be quite alien. And finding the area. Well, with how thick the ocean, the ice is, 6 miles thick, it's not going to be getting any energy from sunlight. At least not any appreciable. It could get its energy from the deep sea vents, if Europa does in fact have any. Or, interesting thing, the intense radiation coming from Jupiter could actually be breaking down some of the ice and some of Europa's weak atmosphere. Once the hydrogen is freed, it goes being blown off, but that leaves behind very reactive oxygen that can react with the ice. And those cracks we saw, it might be able to find its way into the ocean and fuel energy. Okay. Now for the spacecraft. This image was taken of it when it got to Kennedy and was being unloaded from its transport spacecraft. Okay. So, its solar panels are 100 feet long. It has a high gain antenna that is 10 feet across, and it has 24 engines that are used to orient it and power. Yes.
100 foot long, 100 foot on each side, or 50 foot on each side?
They are saying it's over the size of a basketball court. They keep using that comparison.
Okay, so you got 50 on each side.
Yes.
Yeah.
This right here appears to be the attachment. It looks like they separated the solar panels during the transit. Will be showing an instrument in just a bit that actually has a comparison. So this is the Europa imaging system. NASA loves its acronyms. It has a wide angle and a narrow angle camera, and each of them are 8 megapixels. They'll produce the high resolution images comparable to what we see from the Mars rovers. And they'll also study geologic activity, measure surface elevations, and provide guidelines for other spacecraft instruments to make their progress. This thermal imager is going to look for the surface to try and see where it's frozen solid and where there's warmer water that could be melting the ice, where we could potentially have plumes. Plumes were discovered with previous missions. It looks like there are limited plumes that erupt from Europa's surface, though they're nowhere near as fancy as Enceladus. But they're still of interest because it means that there is strong evidence for quite a large reservoir of water. And it'll also measure the surface texture to understand the small scale properties of the surface and how the ice interacts with each other. And this is an ultraviolet camera that also has a telescope attached to it. It will create images, and it will also determine the composition of the atmosphere of Europa. It's gases and its surface materials. It's also going to search Europa for plume activity, as I just mentioned. They're hoping to find that. This is the infrared spectrometer. They have quite a bunch of, they want to look at Europa in every spectrum they can. If they could bring it along, they passed it. It'll map the distributions of ice, salts, organic materials, and the warmest hotspots, which they're going to try and see what the geologic history of it and determine whether or not the ocean is suitable for life. Now, this is the magnetometer, and as you can see, it's quite long. This one is actually connected to the solar panels, one of the instruments connected to the solar panels. It's going to use this magnetometer to determine whether or not the ocean exists, measure its depth and how salty it is, and measure the thickness of the ice shell that covers the moon. It's also going to study the ionized atmosphere and how it interacts with Jupiter's magnetic field. Then one of the interesting things that Galileo and some of the other spacecraft have found that there's actually a magnetic loop that connects some of the moons in Jupiter's magnetic field. And people actually theorized that Io was actually having some of its material carried over to Europa, which that would certainly be a good way to get sulfur. This Europa's ionosphere and the plasma trapped in Jupiter's magnetic field, it distorts the magnetic fields around Europa, which does not have its own magnetic field as far as we know. These little Faraday cups are going to distinguish those distortions from Europa's induced magnetic field, which will give us information about its oceans. And this is going to read the gravity to determine the flex, because Europa does not have a circular orbit, so it gets tugged differently based on how close it is to Jupiter and its relation to its signature moon. By measuring its gravity, they're going to help tell how it flexes and help us tell exactly what its interior structure is. And this is another instrument that is going to be going along with solar panels. This is the radar. This is going to penetrate the ice and hopefully tell us the thickness and exact composition of the shell. It's also going to study the surface elevations, composition, and also search for cliffs. And this one's going to analyze the gases that are in the thin atmosphere. As I said, they know that there's a thin atmosphere of oxygen, which they think is being given off by the ice or some that. It will also study the chemistry of the ocean to determine whether or not there's exchange of materials between the seafloor, the ocean, and the ice, and how the radiation alters the compounds on the moon's surface. And finally, we have the last instrument. As I said, they loaded this spacecraft down with every single thing it can carry. Tiny meteorites eject bits of Europa's surface into space, and some of the material of Europa might get vented by flume. So they're actually hoping that this can catch and study the materials. Now, this is a large amount of instruments for a spacecraft, and all of them are going to be stored in a vault. You can see the vault here. It's made of titanium and aluminum with some steel to help protect all of the instruments from Jupiter's very nasty magnetic field. Any questions about any of the instruments before I move on to the timeline?
Well, it's actually,
Which ones they did not put on there?
No, they didn't include those.
Okay.
There was a long, I know that there was a long list of stuff they wanted to bring, but when they couldn't do the twin spacecraft that they were hoping for, and we ended up with JUICE and Europa Clipper instead, I do believe that there is one instrument on JUICE that NASA contributed. That is probably the poor little reject that couldn't make it onto Europa Clipper.
you sort of touched on my question, but I was actually concerned about Jupiter affecting the instrumentation. So they've actually tried their best to protect the instruments from Jupiter's radiation.
Yes, they have a vault. They call it literally a vault, and it's at least an inch thick. It's the heaviest part of the space. When Europa Clipper launches, not quite, but almost half of her weight is going to be used to get her to Jupiter. And she will be working in tandem with Juno, who has survived the Jupiter environment thus far. So NASA has a good track record with their vault system. Okay, so the timeline. Her launch window, which she will be launching on a Falcon Heavy, and this is pretty much the only image on my PowerPoint that was not provided by NASA. I took this off of SpaceX's website for this. If you would like to pay for a Falcon Heavy, no, but I will borrow your photo, please. Because they're still finishing the loading process. They haven't gotten her fully ready and on staff yet. But her launch window starts on October 10th. And she will be launching from Kennedy. Then she will enter her cruise phase, and there won't be anything until February 2025, when she will do a Mars flyby. The distance will vary wildly based on what day she's actually able to launch during her launch window. This will provide her with a gravity assist to give her additional speed. And as I said, half of her weight when she launches is going to be her fuel. Almost. And then in December of 2026, she's going to do an Earth flyby to impart even more speed to give her the final oomph to help get her out to Jupiter. And finally, in April 2030, she will finally do her Jupiter orbital insertion, and her braking burn, to give you an idea of her speed, will take 6 hours to complete. It's going to take that long for her to slow down for this behemoth catch her. And this is an image of Ganymede, who will be drafted for the purpose of shaping Europa Clipper's orbit so that they put it into the desired resonance with Europa. And as I said, Ganymede is the biggest of the moons in the solar system. It's actually larger than the planet Mercury. And it's the only moon that is known to have its own magnetic field. So, interesting. On spring, they will do their first Europa flyby. And then they will, in May 2033, they will start their first science campaign, which will focus on the anti-Jovian side. For those who didn't know, because I actually had to look this up, this is the anti-Jovian side of Europa. This is the side that faces away from Jupiter. And this is the leading side. This is the side that goes forward, and it is the side that looks dirty. That side in a sec, so. There you go. That one's going to be in 2034. I was trying to get the slides to format correctly because designer was not very helpful. And it will actually focus on the sub-Jovian side, which is this side here. And in a departure from the tradition, the mission end, they're currently planning to end Europa's Clipper's service by crashing it into the surface of Ganymede. Yes, I was going over all of the notes and stuff, and it's like, wait, they're crashing it into one of the Galilean moons. They're not crashing it into Jupiter.
Mm-hmm.
So we're going to have to see what goes on, and it will make things interesting if Juice throws a monkey wrench in that plan with its Ganymede studies. So, are there any questions?
Well, I didn't hear anything about investigating its core.
Those are going to be, well, they said composition and multiple of the instruments they're going to try and figure out, but the way we figured out the composition of our planet was by measuring earthquakes using seismographs. So there's only so much we can do without putting something on the surface. I imagine that's why they want to get big Europa lander so bad, but there's a lot they can do with gravity instruments and tidal.
Could you say more about the, I know it's not core, but the idea of something hitting it and then it's launching a third basically, and then the equipment catching it? How is it gonna, I remember it having a flap, is it gonna open?
Oh,
the
she's
flap?
talking about that.
Yes, you're talking about Suda.
Yeah,
That right
how
there.
is that gonna
Do you remember Osiris Rex? Okay. Basically, it's going to close this at regular intervals and try and study what it catches.
work? What does it do with the stuff that, like, after it crashes it, how does it get?
They may do something similar to Osiris Rex. They didn't really elaborate on this. The way Osiris Rex would have cleared its samples if it hadn't been trying to hang on to them as it actually spun itself. But I don't know if that's feasible with the size of the Europa Clipper solar panels. They may have some compressed air that they can blow the stuff out with. Yes?
So it catches it, analyzes it, and gets rid of it?
Or it hangs on to it. They were kind of mum about the exact mechanics of this. Everything is just like, this is what we're dealing with it. Not necessarily going to tell you how all of it works. They were trying to cover a lot of ground in not much time.
Now, you say the other one is going, that's ESA. ESA is behind that?
Yes,
Okay.
the Jupiter Icy Moon Explorer.
Okay, so they're doing that part,
They're doing Ganymede.
and NASA is the one that's doing this thing.
Yes.
Okay.
The original dream mission would have been a complete survey of the Galilean moon. But poor Io and Callisto, no one cares about poor Callisto. It hardly gets its own mission, but and to be honest, I don't think they want to get anything too close to Io with those volcanoes. Well, oh, we need to do an orbital adjust. Then, Pele decided to erupt at the wrong time.
Well, the thing is, with this, how are they gonna maybe distinguish between, like you were saying, possible stuff coming from Io versus what's coming off the surface of Europa?
Well, that maybe is part of their goal, because they also would be curious to see whether or not material from Io is in fact getting there. Because Europa, as far as we know, doesn't produce sulfur natively, because it's a water. So if it's on the Jupiter side, and it's suddenly picking up a bunch of sulfur where it wasn't on the other side, and is doing it whenever Io is passing by, Io is probably the culprit. Any other questions?
How much do it cost?
No, I don't actually.
How long have they been planning?
The early planning phase, like where they had the dream mission of like the complete survey of the Galilean years, they've been planning that for over a decade. But no, we can't do the giant ESA NASA mission that studies all of them, so we're only going to study 2 of them. Let's pick the cool ones.
Well, we found our budget.
No,
When are you gonna go back to Venus?
I'm so sad that Veritas and Da Vinci didn't make it. That was aggravating.
At least you got Dragonfly on the floor.
That's going to be on Titan.
I know.
I know, but it's
But
like,
that's cool too.
I know, but what about Venus?
Been to Venus over 50 years.
They need to go back to Venus. And it needs to be like, because during the golden age of like space exploration, we had all of the success on Mars, and the Soviet Union had all of the success on Venus. We need to actually go and complete a mission on Venus.
There's only one on Venus that succeeded.
Actually, they don't even consider it a success. It failed to complete the majority of its mission objectives, so they consider it a failure. Yes, but they consider it a failure. So there, technically speaking, has been no successful missions to the surface, if you go by the space agency that sent its criteria. So we need a successful mission to the surface of Venus.
Why hasn't there been successful one? What was the problem?
That is good.
And the fact that Venus is the hottest planet and it squishes and melts anything that lands on it.
So any atmospheres of pressure on the surface, and at the surface it's like 400 degrees hot.
800 Fahrenheit.
Well, that's like the winds are 300 some odd, the surface is.
They call it Venus the sister planet. Yeah. I said, well, we getting there.
Oh, and like, let's not forget it rains sulfuric acid, but it's so hot it never makes it to the surface.
Year 14, was it?
I believe so.
I think it's 14 is the one you said.
Yeah, the little camera cover melted. They actually caught an image of it turning into a little photo of plastic.
So all that's left of our missions to Venus are clothes of plastic?
And metal.
I remember that was back in the 70s too.
And they call it the sister planet, right? A sister planet.
I've heard it jokingly said that it's Earth's evil twin, but some people have said that when the sun gets bigger and we get hotter, we're going to become Venus's evil twin because we have more, with all of our water, we're going to have more greenhouse gases than Venus ever did.
Yeah.
Anything else? hoping he gets an extension. They extended, yeah, they extended Juno, because Jupiter hasn't killed it yet.
Yeah. We keep going,
I
right
couldn't
now.
get any work they wanted to do.
Juno still has its planned destruction orbit, where they can send it
Well, yeah,
to
but
the pole.
They were originally planning to put it in a much shallower orbit that was.
But now we got.
Thank you very much to Amy for giving us that wonderful presentation, and this will conclude the public portion of the meeting. So thank you for joining us. And for everybody else, I'll be back to finish up the meeting. I'm running double duty right now.
Yeah, I remember.